welcome you all for today's session for our workshop on bringing math to life with Geogebra Applets. Yesterday, we dived into this world of Geogebra with Dr. I.K. Rana and learned some basic tools and techniques that are available. Today, we will go a little further and get to know some more tools that can be used with our today's resource person, Dr. Surendranath Reddy sir. I request Ms. Sanchita Rani to introduce the resource person. Over to you, Miss.
Yes. Hello, everyone. Good afternoon, and welcome to second day of workshop on GeoGebra. I'm Sanchita, and I'm honored to introduce our resource person for today, Dr. B. Surendranath Reddy. Sir is currently working as an assistant professor in mathematics at School of Mathematical Science at Swami Ramanand Tirtha Marathwada University, Nanded, Maharashtra. So completed MSc from Hyderabad Central University, and during his MSc, that is in third semester, so cleared CSR net with JRF. Completed his PhD from same university, that is Hyderabad Central University. Algebra analysis and subset theory are his research area, and have published more than 25 research papers with 75 plus citation. So far, sir has guided two MPhil and four PhD students, and currently three students are pursuing PhD under his guidance. The most important thing about him is that he's well known for his technological expertise and using it in teaching learning process. He has organized faculty development program and trained around 70,000 teachers on ICT tools for online teaching and delivered more than 50 invited talks during COVID-19 pandemic. Sir has a big contribution in mathematical e-content on topics such as functional analysis, lattice theory, topology, etc. Sir, today we are very happy to have you, and thank you so much for taking time from your busy schedule. Without further delay, let's give a warm welcome to Reddy sir. Sir, over to you.
Thank you. Thank you, Sanchita Rani ma'am. And I would like to thank Rohit Redkar. Am I audible?
Yes, sir.
Yes, sir.
Okay. And I also would like to thank Brian. He's my friend, colleague. So he asked me almost 4 or 5 months back that we will be planning like this. Then I said, okay. And yesterday, we have seen glimpses of GeoGebra and constructing some applets. So today, I will be showing some applets as well as the other things which uh, one should know about GeoGebra, like what are different types of things are available, what are all we can explore with GeoGebra. Then I will continue some applets uh, where maybe I will touch some small three-dimensional one where you can understand topics very clearly. That is the main use of this GeoGebra. Okay, so let's. Um, anytime if you have any in between, if you have any doubts, any query, you can stop and ask me. This is not a lecture; it is actually two-way interaction. And I hope afternoon you may not be feeling too sleepy. So if you are feeling sleepy, you can ask a question. Okay. If I know, I answer. If I don't know, then I will answer later. Sorry. Let me share my screen. By the way, how many of you tried yesterday, whatever sir has discussed? You can say yes in chat box if you have tried something. Whether you tried yes or no. So, Sudeep Naik, you have something to say? I hope my question is clear. I asked, how many of you tried GeoGebra, exploring GeoGebra, whatever sir has discussed yesterday? The answer should be either yes or no. Only two things are possible, right? Hmm? So not only one said no. Okay. What about reminding all participants? Whether you are not interested, just want to the reason to keep 2 days instead of having two continuous sessions is that you might have tried and have some idea or have some doubts. Then next day we can clear it. But that purpose was not served. Okay, some person because he's knowing yesterday topic, so he didn't try. What about others? Do you have any doubt? Somebody raised hand. You want to say something? Okay. Let me share my screen. Okay, so can you see the screen?
Yes, sir.
Browser. Okay. So I'll quickly show you where you can. So with that information, I will show something. Then we'll go back to creating some applets. Okay. So you can go to simply type GeoGebra. Geogebra.org is the website. Okay. So this is how basic website look like. Here you will have a login option. Everyone can have your own login. You can create a separate user ID password, or you can log in with this Gmail or Yahoo, whatever credentials you have. And this is how it look like. What are all options available? This left hand side, you have the home button, news feed. So whatever news related this GeoGebra, you can find it here. Resources. So this is one of the best advantage in GeoGebra. Whatever you prepare, you can make it available to anyone. Anyone can take it. They can use it as it is, or they can modify and they can make it as his own applet. For example, I have created something, then that I upload it, I make it available to everyone. Somebody can use it as it is, or they can use it as per. I mean, they can modify it and they can publish it. Okay, one can have people. You can find different peoples. For example, these are the so many people you can find here. Okay, and if you like someone and if you want to follow, you can follow that person. If you click on this follow, you will follow that person. Whatever applets he do it, then it will be automatically visible to you. You will get a notification. For example, I'm following these two guys. He is the best person I can suggest. This Tim Brzezinski. He has done excellent work, lot of contribution to this GeoGebra. If you just click on his name, you will see a lot of things he has done. Okay, uh, here everything, most of the things he has done, and as I said, you can start using it. You can learn from him, and you can use those things also. Okay, so let me show one. Suppose, yeah, suppose corresponding angles. If you want to know this one, you can just click on this, and here it is ready. You can use this. Okay, whether they are of same angles or not, you can check that. You can change. These are all sliders. Yesterday we have seen. Okay, that what we get with different sliders. And if you want to use this one, or if you want to share it to someone, you can use it this. There will be some questions one can write it. If you are a teacher, if you want to make your students to work on this, you can make it like this. And this mm, yeah, here right side, if you click on this, you will have different options. Open in app. So if you click on open in app, this applet will be open. You can keep saving, editing, or you can copy the activity. Or this, if I click on this open in app, so in this GeoGebra Classic, it will be open. Okay, so this you can see here, it is open, and we can start using it straight away. And if you want, you can make changes. Here there are many things are available. You can make changes and you can save it that as your own. Okay, so any resource available on GeoGebra, you can use it. You can try to understand what things are going on. Okay, and if you want, you can make some changes as per your understanding or as per your things. Then you can use it, that you can save it and you can publish it. Okay, so this is one very interesting one. I'll show you how you can publish it, how you can share it with others. So let's go to this home again once again. So this is very good resources. As I said, if you are really interested to learn, you have each and everything. Almost all resources have been covered. You take geometry, you take algebra, whatever things are required, they are already done by someone else. So either you can do it on your own, or you try to understand from those resources, create your own. And if you are a teacher, you give to your students. Okay, here GeoGebra also has a classroom facility that I will don't explain much, but you have a classroom. You can click on classroom, and then you can usually you share it. Then there will be a code. Once you join that code, you will be joining as a student. Okay, that I'll skip. I interested people can learn that. Then in this center one, you will see straight away you can start using start calculator or classroom resource. Okay, and below you have some apps like calculator suite, 3D calculator, this CAS calculator or geometry. That means GeoGebra has actually different parts. What you are using, depending on that, you can select the suitable one. Okay, or there is also called GeoGebra Classic. So in this GeoGebra Classic, all will be there. You can select which one you want inside that. Okay, so if you click on this GeoGebra Classic, this straight away open. Okay, this is how it look like. It is GeoGebra 6 version, but doesn't change much with Classic version 5. Okay, so I'll come to this little later. This GeoGebra you can work in two ways. Online, if you have connected through internet, you can directly open through browser. It will be saved. You can download it and you can work it on your computer also. Okay, so if you want to download, you can click on this app downloads. So once you click on this app downloads, you will see a lot of options here. The basically thing is, if you want to use a particular one, for example, you want to use only for related to something three-dimensional, so then you can just download 3D calculator. Okay, or if you want to just use for some graphing purpose, then you can use this graphing calculator, because each one will have it is just like sub tools. Okay, so if you combine all those things you want, that you can use this calculator suite. Okay, this calculator will have construct geometric shapes and 3D objects, explore functions, solve equations. These things will be there in your calculator suite. And geometry, it says especially constructing geometrical shapes. And graphing calculator means plotting graph and trying to find the roots or how that look like, slope, all those things. Okay, then this GeoGebra Classic 6 and GeoGebra Classic 5, these two have all the whatever you have seen here, different independent, they will have all these things, including free tools for geometry, spreadsheet, probability, CAS. Okay, that means you can solve some equations, all those. And some many from many days, this 5 is also available. Okay, if at all are there any bugs that we may find it in Classic 6 because it is relatively new compared with Classic 5. Okay, so either you can use Classic 5. Only thing is this Classic 5, you have to download and start using it. You can see here this Classic 5, they made it now only option to as a work. You have to download and use it as a desktop app. Whereas from Classic 6, this is either you can download and start using it, or you can start straight away from using web browser. Okay, so this is all about the different things available, features available from this GeoGebra website. Here, this resources, as I said, you can click on this. You will see once you click on resource, you will find a lot of things here. Okay, whatever you want based on that, elementary or high school, they have classified into different things. Here you can see that they have even made it like a tree: geometry, arithmetic, statistics, functions, algebra, probability, calculus, trigonometry, or you will have different types of things. Many people have written even books also. Okay, so you can find any resource and you can start learning yourself. So whoever going to present or prepare your applets in your competition, these resources will be very useful. Okay, that whatever you want to learn, they are already there. Just understand properly, and instead of implementing as it is, you create your own applet. Okay, for that, these two lectures are just I can say foundation, or just give a direction how you can go ahead. Okay, you will never miss any point. From resources you can find everything. Okay, for example, just I will for to show you, say for example, I will type here equilateral triangle. Okay, then you will find here lots of already developed uh, resource, this applets equilateral triangle construction. As I said here, this Tim by Tim, or many other people have constructed different ways. Okay, you can just go through it, and you can open, as I said, you can open always any applet. If it is available on resources page, you can open it in GeoGebra app. So let's just quickly show you. For example, this I want to understand this, and I want to uh, see what are all things are available here. Okay, so here you can see these things. It is a slide. Okay, right now if you want to know, understand how things are written here, what are all things are written here. So for that, you have to open this applet in GeoGebra app. So as I already explained, you go here and you click on open in app. Then this will be open in app, and you can understand everything that what they have done here. Okay, by showing here, if you click on this, uh, it says what are all you can view it. For example, here if I click on algebra, then whatever things are here, these are the things which he has constructed, okay, to get this applet. So algebra is available. You can understand what things are done, what are all slides are available, how many different things, how they're constructing it here. Okay, they initially started with 2 points, then joining everything. So you can understand on your own, and accordingly you can have it different your own ways. So this is one of the best way of learning GeoGebra is use resources. Whatever resources are available, get some idea. And as I said, everything, if something is available in a resource, it is open. You can open it in GeoGebra app. You can make any changes. I can suppose, for example, I can remove this. Okay, I can remove this, or I can add something. Whatever I want to do, I can do it. And finally, if I want to make it, I can make it as a save option. Okay, and once I save it, I can keep it myself, or I can share it with anyone, or I can publish it also. Okay, so there is something not like copyright problem, all those things. It is free to use, free to edit, free to distribute, in the sense open source. Okay, and it is the only app available having such type of feature. Okay. So this is one about resources, and I already mentioned about people, right? Now let me go back to again once again home. This is home. Here we have this whatever, just like in Google, what we have here is whatever different things are available: calculator suite, graphing calculator, geometry. If whatever we require, you have some notes also. You can keep something notes. You can start pen. It supports. You can start writing. If you want, you can do directly go to GeoGebra class. Okay. So remember, everyone whoever using it, try to have a login so that whatever you save it, it will be already available. Okay. So you can let me sign out and show you how GeoGebra look like this. So this is how basically it look like without sign in. So here you have option called, if you click on sign in, then either it will ask sign in with Google, Facebook account, or you have Microsoft everything here if you click, or you can have your own GeoGebra account. You can register, create an account, and you can have that credential. So I have created already, so I logged in. Now whatever, if I click on this, whatever things I have some resources. Okay, I have some favorites, I have some people, some groups. You can have all those things. For example, these are all the resources which I have created. So these resources, anyone can accept it. Okay, the moment I publish it, then anyone can access from GeoGebra resources. If I don't publish it, then it will be acceptable only for me, or I can share with, without publishing, I can share it. So it is just like, I don't want to publish, but I can share it with particular few people. This is available. Okay. For example, how, if you want to know this one, how we have created and whether it is published or not, if I click on this, the few things it will show. Okay. Open in app, publish, assign. So the moment if I say publish, it will be published, so it will be available. Okay, it will ask some name, and with that name, if someone search it, one can find my resource. Okay, so whatever small things also you create in GeoGebra app, you save it. The moment you save it, it will be seen in your resources, and you have option to share. If you click on this copy activity, if I click on assign, you can assign to someone. If I click on publish, it says here creating a mug, where under which topics you want to create, whether it is an algebra, geometry, arithmetic, mean, whatever you take it and select subtopics, whether it is a practice, tutorial, relevant one, then you simply click publish, it will be published. Okay, so that others can access your thing. Without publishing, if you want to do it, see, for example, here there is a difference between these two. Here there is a code, and here it says shared with link. That means it is not yet published, whereas it is published. Okay, that means this is available. If you search with this code, it is available on this resources page. Okay, and this GeoGebra also has app, mobile app, where you can use that augmented reality. That I am not using this today, but it is very very good. You can bring the virtual picture on your table, on your wall, and you can explain many things on that. So GeoGebra, there is a app called GeoGebra 3D. If you download that app on your mobile, then you can create this virtual, for example, this mug or whatever you take. For this, you can create the virtual 3D, and that you can compare and putting your on your table virtually. Okay, that means you can create three-dimensional shapes, and you can compare whether they are prepared well or not using that virtual diagram. Okay, but so what things are there? This is quick about how you can use resources, how you can create a login, how you can save it. Already sir explained yesterday. Once you save it, it will be already here, and once saved it, you can either share it with a link or you can publish it. Okay. These are the basic things you require for using this GeoGebra. Okay, and I suggest everyone create, instead of just practicing like that. Without login, also you can practice, and without login, also you can download it. But once you have a login, whatever you do, it will be once you save it, it will be there in your thing. Okay, no need to separately download that one and keep it in on your desk. Okay, fine. So let me go to this. You have any doubt here up to here? Hmm? Yes.
No, sir, it is clear.
Okay. So let me take to this GeoGebra Classic 6. Is almost similar to 5, whatever is there. These things already you have seen yesterday, like different types of, this is toolbar, different types of tools are available. Okay. Uh, Sir, yesterday shown how to construct a square thing, right? Square. Huh?
Yes. Square,
And
triangle.
how to check whether it is a square or not, how to measure angles, all those things. And he also explained a little bit about slider, right? Slider is basically a value which can be changed. It is not a fixed value, dynamic value. Okay. This is this tab, whatever you are having here, it is, if you click on this, there will be options, different options called slider, text. You can insert an image, you can insert some buttons, you can have some checkbox. For example, you want to create some questions and all, you can have it. And you can have it in input box. So for example, x square is your function. If the moment you give 2, the output will be 4. Like that, you can create many things. So just say click on slider. So the moment you click on slider, it asks you put some position. Okay. Suppose I put some position here. Then it asks, there are basically three types of sliders. One is depending on number. So it means it like 1, 2, 3, 1.1 like that. Or it is an angle, or it is an integer. Just like 1, 2, 3, -1, -2, minus. So it is a continuous one, whereas it is an angle and it is an integer. Okay. So this, and you will also have like if I click on slider, then you will have minimum and maximum with increment. If you don't give any increment, it will be, if it is a number, it will be continuously increased. Okay. If it is an angle, it will be continuously increased. If it is an integer and if you give an increment, it will be in that way. Okay. This is an interval. It is a slider, fixed, a random. What animation type you want, how much speed you want, all those things. Whether you want repeat these things. Okay. So first let's take, say, suppose number, and I want to say 0 to 5, or even say 1 to 2. Okay. So this is created. You can check that these values are changing continuously, not just numbers. Okay. 1.1, 1.2, 1.3, like that, right? So let me put this little up. Fine. Now, how one can use this slider? It is basically a number. Okay. You can use in different ways. It is just like, can somebody tell what way you can use this slider? For what are all purpose you can use sliders? Let me create one more slider. Okay, so suppose I will call it B. I will also call 0 to. So we have created 2 sliders. Okay. Now tell me what all we can do with these 2 sliders. Because we keep on saying and you will learn only those many things. I just asked one question. What are all we can do with these 2 sliders? What type of things we can do with sliders? Yes. Until unless you know what are all you can do with sliders, then only you can use slider. Otherwise, what is the point of knowing slider? Slider means it's just like moves here and there. That is, if you know that much, it is not sufficient. At least one example that how you can use slider.
Scaling, sir,
Scaling for what
for
sense?
the graph.
Huh?
Scaling,
Yeah, scaling. But what in exactly what? Scaling means how?
like the class intervals which we take.
These are 2 values, right? It's like, for example, just like 2 points. Okay. Only difference is these 2 points are not fixed. They can be varied. Okay. So using 2 points, what are all you can do? using 2 points in the geometry, if you are a mathematics student, yeah, yes, you can say it, Grison. I'm just saying I have given 2 points. Okay. Then using these 2 points, what are all we can do? If you see from this toolbar, huh? We can draw a line segment. Yes or no? Yes. We can draw a line segment or not?
Line segment.
Line,
Yes.
line segment between 2 points. Okay.
Yes.
That length I can give it A. That means if I say A is say 3, that means you have line whose line length is that line segment whose length is 3. Then if I change this line segment will increase. Yes or no? Then what else other we can do? This is basically like length. Okay. You are changing the length. So where you can use the length? Between you take 2 points and the distance between those 2 points, I can make it as A. The moment I change this A, those 2 points will be changed. Right? Or this distance I can use for a radius, circle radius. Okay. And what where else we can use it? Suppose this, let's construct this, right? Suppose you want line segment, right? So what it says here, if I click on this, the moment I click on this, here it explains what is required for segment. Select 2 points or position. Okay. So I'll select this 2 points, 1 and 2. This F is fixed here. Okay. This F also we can keep varying. That if I make it a line segment, right? If I say suppose A, then the moment I change A, this will keep moving, right? Or say for example, let me put 1 point here. Let me put 1 point here. Now moving. So let me put first 1 point. So I'll say suppose I'll put it here. Now I want to construct a circle whose radius is just A. Okay. That means A is length, radius, and it will be keep varying. So let me construct a circle with center through point or through radius. Okay. So the moment I'll click here, then it will ask radius. So I'll say A because I already defined here. A and B values already there. So the moment I click here, it is there. Okay. So here, if I keep changing this is varying. So I get different types of circles. Okay. Let me create one more circle. I'll put one object, 1 point on that object. Suppose I'll put a 1 point here. Now I'll construct one more circle. Okay, so circle with radius. Okay. So I'll select this as my radius and say I'll select suppose as B. Then it is already there. So this, right? Now if I keep doing this, once you can have different types of animation. Okay. And not only this, so here it is like two things are varying. That radius of these two circles. And if I pause it here, suppose in this geometry you can see there are two circles. Circle A comma A, circle B comma B. So I'll right click this. I'll go to settings, or I can click on say suppose show trace. Then if I click on this, this, because I have made it trace, so it will keep doing this one. The moment how it is going bigger, it will start tracing. You can obviously change the colors. This color is not so good. Okay. And you can create wonderful animations. That means, say for example, if you want to create a flower, just like a flower which is moving, so you can create some 5 to 6 circles. Okay, you will get just like a flower type shape. You can give different colors, and you can use these sliders. And if you start using animate, then it will give nice way of creating a applet which shows that like animation moving circles are just like a flower. Okay, so that way you can use these sliders, right? If you want to use text, then you can use text. Say if I want to have some text here, this says I want to write what is this one. I can say this is two moving circles. Okay, I click OK. This wherever I want, I can keep it. Wherever I want, I can put it. And if necessary, I can make those things I skip there. You can make whatever you want. Okay. You can see that those two circles are actually moving. One is moving up, below, because the center is, we kept it there. Okay. So it is all about how you use sliders is most important, right? Then you should have an idea on different places how I can use a slider. This is just a number. You can also have a angle as a slider, and you can use it in different for a proper way how you require something, an angle. Okay, so that it goes via angle, you get a better shape. Okay, just like say assume that you are doing some surface revolution. Okay, you take something and try to rotate it through alpha, then you will find that say suppose just have a circle and you have a line, then you keep rotating it, you will get a cone. Okay, that is how you can create different things. Fine, let me clear this, I don't want to save it. So let me quickly say, because sir asked me to explain one. Say for example, congruent triangle. So what is meant by a congruent triangle? How we will say two triangles are congruent? How we'll say that two triangles are congruent? Yes. If as a student or as a teacher you want to verify whether something is congruent or not, how you will do it? How will do it? There is a difference between congruent and similar, right? Yes. In congruent triangle, what we'll have? I will check congruent. Whether you are there or not?
Yes, sir. Same shape and same size.
Same shape
And same
same
size. Having
same
same shape and same size. Congruence.
like same side lengths of should be same, corresponding lengths, right? And angles. Yes or no? Okay, so let me
Sir.
put some 3 points quickly. I'll show you what are all one can do. So suppose I'll put some 3 points here. Okay, and you can join, you know all how to draw a triangle. So you check polygon and select this here, here, and here. The moment, see, this is why it is called GeoGebra. So it is a one side you have geometry and the other side you have algebra. So you can either go from algebra to geometry or you can go from geometry to algebra. It is very easy to go from geometry to algebra. Okay, instead of algebra to geometry, we have just clicked 3 points here and then joined. You can see that many things have been mentioned. Okay, now you can do many things for this triangle. For example, if you go to this tool, this is about reflection about a line, reflection about a point, reflect about circle, rotate around point, translate by vector. Many things are there. Okay, so let me say suppose try with this reflect about a line. What this says, it is already self-explanatory. You can see below that the moment I keep cursor here, it says that select object to reflect, then a line of reflection. See, suppose I want to rotate this one, so I'll select this. I have selected this triangle. Okay, now I want to rotate this through a line. Suppose I select this y-axis, then you can see that it has immediately rotated here, reflected here. Is this clear? And how these points A prime, B prime, C prime have been created. You can see here A prime is, it is basically reflection of the point A through this y-axis. So if you see, this is exactly reflection of this one. This is exactly the reflection of this one. And okay. So basically congruent triangles, whatever you are having, okay, even though they are not exactly, so question is whether these two are congruent triangles or not. Whether these two are
Yes,
congruent triangles or not.
Yes,
Yes or
they
no?
are congruent. Yes, sir.
They are
Congruent.
congruent. This much at least everyone can say it, right? Huh? Only except one or two people are listening. So even though immediately if we see this, shapes somewhat looks different, but actually they are the same, because what we did, we have not did anything. We have simply reflected this one, right? Yes or no? You can also reflect about a point. Suppose I select this, then select the object to reflect, then center point. So suppose I select this object and I will select this A. Let me reflect about a point, reflect about circle, select object to reflect, then center point. Okay. So I'll select this, and why it is not working here? It is working. This one is reflected about this point. So whatever this point is there, it is reflection of that one. That means this point is a common point there, right? Okay. You can similarly have a reflect about circle. So you have something and then you take the circle, rotate around a point. So if I click on rotate around a point, then if I click on this, it will ask for the how much. Let me rotate around a point. Okay. So I'll select this object, then I'll select here. It will ask how many degrees you want to rotate, and counterclockwise or clockwise. Suppose if I say 60 degrees, click on OK, then this is rotated. Okay. So different ways you can have triangles, and why we can use this one, you can ask your students, if you are a teacher, to explore such things that give two different shapes of, I mean, triangles. They immediately not looking like congruent, but by this reflection or rotation, they can able to see whether it is same or not. Just let me take one example, how an example, so that you will see how one can make it interesting for students. uh, Suppose if we see this, proving triangles congruent with one step transformation. That means, so here, this is the picture. Can everybody see this picture? Now question is, how can we make it this? How can we prove that these two are congruent by just using one this transformation? Okay. So what we think here, we have to rotate, we have to reflect. How we can reflect this? Huh? If you see these two images, it is clearly one is reflection of the other through a line. Yes or no? So if you go here and reflect about a line, and you select this object, and if I select this line, then you can see that this is exactly the reflection of this, right? Or you can create something. If I want to make it this one and here, then obviously it is a reflection of this through this line. So if you go here, reflect about a line, and select this image, and if you click on this, you will get, right? So such type of things are there. Now here, how you can see this one? It is translation. Yes or no? This one is coming as it is here by means of translation. So you can check that how it will be here using different word. So one can explore and you can make it things interesting, and you can also understand how many different ways we can do it. Right? This is one just example. So you can also have different types of reflections, all those things. Here line segment, this line point of intersection we have seen, and this in this slide we have seen, and image. So you can insert any image also if you want, and you can start exploring about that. Suppose let me see whether anything is there in my. You can put anywhere here if you wherever you want. Okay. And this for this image also, you can make it whatever things you want. You can rotate this one. This also have 2 points, E and F. So this E and F are there. Based on these 2 points, you can use it, and you can rotate, you can reflect, whatever you want, you can make it using these images also. Either you can create, or you can insert images, or you can put some text, because sometimes it is required to explain some things there. Using text, one can use it. Okay. You can also use the button, like button. So it asks where you want to put a button, and it will ask what is for what purpose and what should it act as. Okay. So if you have suppose define a function f of x is equal to x square, then this is just like uh, evaluating that value. Then if you click on that and substitute say x is equal to 2, you have to write that script. It is little advanced, so I don't explain today, but you can write a own programming like script, and it will calculate that. That means the moment if you click on that, it will give the output. Okay. So it's like code we are doing it, and the moment you enter input value, it will show the output value. Okay. This, you can have a freehand shape. So let me explain for that. In this GeoGebra, you have a freehand shape. That means suppose I draw with my mouse, this it understand that it is just like a this, right? If I draw like this, then it is like 4 sides are there. Okay. And it also creates the points. That means either you create through this, or you can create through this freehand also. Okay. And you can write using pen also. It is useful, right? Let me explain. Is there anything in this before going to 3D one? I hope he explained intersect, attach or detach a point and object. Okay. Then line segment, all those things mentioned. Race, perpendicular bisector, and regular polygon, different types of circles, ellipse, parabola, and angles. You can have an angle with given size, distance, length. Okay. List I'll explain later. This we have seen reflection about different types of line, point, circle, and this sliders, text, images we have seen. This already sir mentioned whether it is to zoom in or zoom out. Okay. So you can using this basic you can say graphic geometric tools, you can construct whatever shape you feel like and whatever ideas you are getting, and you can create an applet. Applet means whatever you create it, once you save it, it will become an applet. That's all. Okay. How good you will create that applet, it all depends on your input. Suppose I just put this one. Okay. Then if I keep saving this, the moment I keep saving, then it becomes an applet. Okay. That's all. If I simply say circle, right? Circle, then you click on save. Now it is already become an applet now. I can share it with anyone. What it has is having only this circle information. I can write it. Say I don't want to simply save it like this. I'll just add it here as a text. I'll put it here. This is a circle. Okay. And if I want to keep it even more, I can say center is A and passing through B. Like that, I can mention it. If you want to put it sliders, whatever you want to make it, the way, just put a point and save it. That is also an applet. Okay. How much useful or resourceful applet we prepare, it makes more and more sense. Okay. Fine. Now, let me show you a small example of three-dimensional shape. That means 3D calculator, because this is basically just like a 2D calculator, 2D one, okay, app. So to have a 3D, either you can click here or you can go and any doubt up to here? Hmm? Anyone want to ask something? Yes. Hello. Is anyone connected? Afternoon sleeping. I I will also sleep. Huh? Okay, fine. I hope you are all listening. I don't know why you are not replying it. So let's show you some how a three dimensional objects can be seen. This is all what we have seen is basically 2 dimensional. Okay, so let me close this. I'll leave the page. Here I'll go to this 3D calculator. Okay, if you want to use this basic geometry, you can use it. This is a 3D calculator. So you have a plane and you have 3 coordinates: x coordinate, y coordinate, axis, 3 axes, x, y, z. Okay, fine. How many of you know this Riemann sphere or stereographic projection? Hmm? And what are all available here? If you click on these tools, many tools are available here. They are all basic spheres, basic tools. And if you click on this more, you will have n number of tools available for 3 dimensions. Okay. See, these are all 3 dimensions. You can have a point, pyramid, you can have a cube, sphere, plane through 3 points. Okay. Intersect two surfaces. You have something called net. I'll show you that. Okay. Then you can have point, these intersections which you have seen already, means using combination of 3D and 2D dimensions. Then you have solids, pyramid, prism, different types, cone. Okay. Then surface of revolution. This you can with single. There's just like you can create from 2 dimensional to 3 dimensional. Okay, planes. All these things you can use it in this 3D calculator, a 3D graph you can call it, like 3D rotate graphs, all those things. Let me show small things first. So let's say suppose I want to put simply a sphere. Okay, if I click on a sphere with center, and so I'll put it center here and a point. Okay, so you can see that this 3 dimensional picture is created. Yes or no? Yes. So if you straight away see like this, it just look like a circle. Okay, and here if you look it in this way, exactly it's just like a sphere, upper half sphere, and below it is just like, right? Okay. If I see this algebra, this sphere equation is already here. Let me erase this point. Okay. Now again we are just like, right? You go to tools, you can create, say for example, cube. So if you want to have a cube, 2 points, select 2 points or other corresponding object. So suppose I will select this one. Okay, and here then your cube is ready. Okay, because basically for a cube what you require is 2 points, or you can give a length, then cube will be created, right? And if you keep this moving these 3 points, these 2 points, then you will have. Okay, now the here in 3 dimensional you have something called net. So if you use this net option and if you select a polyhedron, then this is called net. That means how you can teach how one can prepare a cube. Okay, so here if you go to algebra again, for this cube, for this net, this slider is prepared. Okay, so if you keep animating this, you can see here one can know how to prepare a cube, how many ways you can ask students to, with the help of matchbox sticks, one can prepare, or they can take the piece of papers, cut it into equal parts, and they can make cube by joining like this. So this net is basically whatever we have this three-dimensional one, it try to make it open so that you can see how things are going on there. Okay, this is one. Then plane through 3 points, just like if you have you want line through 2 points, just like for a plane you require 3 points. So if you select any 3 points, so I'll say suppose this here and here, so then we have constructed a plane. Okay, whatever you don't want, you can hide it, or you can remove those things. I can remove this cube, I can remove this net. Okay, then what we have created just now here is a plane. So this you can see here, this is a plane passing through those 3 points. Okay, fine. So let me show you some interesting one that at least in my MSc students I teach using this GeoGebra, how one can understand this stereographic projection. Okay, how many of you know stereographic projection, a Riemann sphere? Yes, whether you know or not. Quickly, whether anybody know Riemann sphere as stereographic projection? How one can see it? Complex analysis. Whether you, how many of your teachers here are students? No. Okay, I'll explain. What about others? Only one participant is responding. Like just like Rana sir, you want me to call by name and make absent? Huh? I will ask someone. If you are not responding, I will ask. Physics. Whether this three-dimensional one is it clear? How you can create a small 3D shape? Yes or no? I have not said anything very difficult so that you can't understand. Whatever tools are available, using those tools, we have just created few three-dimensional shapes, right? Okay. So let me show you this. Try to understand this plane. Whatever you have paper, this paper is just like a, whatever you are seeing here, it is just like a paper. Okay. Now let me put a sphere on that. This one. So let me select this, and yeah. Okay. So let me make it some color, transparent color, so that we can see things better. Okay. Now I think you can see it. Let me even make it transparent. Okay. Now this is one. Okay. So we have, let me change this. Let me change it. You can go to color. Okay. So that you can see from below also what is there. That point A is below. Okay. Now, as I said, how can you, from paper, how can we prepare a sphere or a closed ball? I have given a plain paper. How we can make it as a sphere? That is the question. Can somebody tell? I have given a paper. It is just like one paper, right? How you can make it this paper into a ball shape. Yes. How we can make it that into a ball shape? By joining this all end points to one particular point. Yes or no? Yes. Is that clear or not? So that we will see here how you can make it basically. That means any point on this plane, we can actually map it to only one point on this sphere. How we can do it? So suppose I want to put one point on a plane. So let me put a point on plane. I kept this point as a C. Okay. C is a point on this plane. Right? Now, let me join. So where this C will be mapped to a sphere on this. So, okay. So now, how we can see that where this point C will be mapped to this sphere? Obviously, we will try to join this C and B here. So let's use this tool, that line segment. Okay, so between this point C and this point B. Okay, now if you see this here, this B and C, when I join, it has intersected at this point. So you can note down that point also. Let's click on this intersect one and I'll click here. So this line and this sphere, that point of intersection is this. Okay, that is this D. So D is the point of intersection of this line CB and this sphere. Okay, now you can move it here and there, and so that you can see, because this C I can move it. So you go to select this move and you try to move this C. So if we try to move this C, what we are observing? Yes, can somebody tell what we are observing if we move this C? The moment we are moving C, this D is different. Okay, that means every point on that plane C is mapping to different point on this sphere. Okay, and the moment I go far away from this sphere, this D is approaching to B. Again, you check here. The moment I am coming close to this sphere, then this point D is far away from this B. And when I go far away from that sphere, then this D is going close to that point B. Is that clear? Yes. You can check that. The moment I take C close, that D is coming far away from B. Okay. You can take anywhere C. So that shows that every point in this C is mapped to some point, right, on a sphere. Different point on a sphere. You can do this same thing reverse also. That any point you take on sphere, then join B and D, that will cut. If you have a line, then it will cut that paper at one point and that point will be mapped, right? Now what is this Riemann sphere or stereographic projection? Is that here every point on this complex plane is mapped to one and only one point in C except this point B. Okay, that means no point will be mapped to point B. So where will be B mapped? Or the other way, every point in this sphere will be uniquely mapped to a point in this complex plane except the point B. Okay, so this B is something called point at infinity, or you can call it extended complex plane. You can call it this as like a north pole. So this north pole, where it will be mapped is the question. So this will be mapped because whatever other point you take, then by joining this B and D, you get some point. But where will be B is mapped? To map a B, you require one more point. This B is already a point of reference. Okay. So this B cannot be mapped to any point in this complex plane So this will be mapped to point at infinity. Okay. And there is something called, I don't know how many of you know it, neighborhood of infinity. So because this B is mapped to infinity, therefore points near to B are nothing but points in the neighborhood of infinity. But what are the points near to infinity? They are the complex numbers which are very far away from this unit sphere. So the moment you can check here, the moment I come close to the unit sphere, this D is very far away from B. If I move here and there, then it is going close. Yes? Yes or no? So this many students develop just like a project by taking a transparent sphere and taking a plane of piece of paper and put it in between this, just like what you are seeing here, and see where the points of this sphere are mapping to the complex plane, or where the points of complex plane are mapping to this. It is a nice way one can prepare by explaining many things here. Okay, it is just like I mentioned only few things. One can explore. See, for example, I'll just ask one question. I don't know how many of you can answer it. If you see this, inside this one, that whatever paper is there, that is inside you have. Okay, where are those points will be mapped? Those points will be mapped to this below the sphere, below the half sphere. Okay, because from the moment you join this B and the point in this inside, it will cut this sphere here. Okay, that's why that whatever paper which is inside this ball, that will be mapped to this the upper sphere. Is this clear? Yes? Yes or no?
Not
How many
fully,
of you
sir.
are
Not fully,
able?
sir.
Huh?
Not fully.
Not clear?
No, sir.
Yes. So what I'm saying, you have a sphere and you have a paper. Okay. So it is about, you take any point, say this is D is a point. This D is a point which is on sphere. You want to map it to a point on a complex plane, which is a paper. So how we are doing it, you join this B and D. It will, if you extend that line, it will cut definitely at this one point, that is a map to that point. Now, if you take any point below this sphere, then where it will be mapped to the complex plane is the question. Okay, that means if I take any point, so let me put some point on this sphere. So suppose I put this point, this is F. Now let me join this F and B. If I join F and B, let me join this F and B, right? Now, if you see this, where is it is intersecting? It is intersecting here. That means it is that intersecting inside whatever paper is there, that it is intersecting. If I change this, then it is changing here. Okay. The moment you come outside, that will be mapped to different. This you will understand and visualize properly. You try to understand, you have one ball and you have kept one paper in between. Then try to join. This B is always fixed. You can call it as a north pole. From that point, you try to join any point in the complex plane. That means on a paper. You will see where it will cut. It will cut exactly at one point. Okay. So those points will be above sphere if your point is outside that ball in that paper, and whatever paper is inside, if you try to join that B and that paper, it will definitely cut below this. That's all. Okay.
Oh, thank you, sir. Thank you.
This is called stereographic projection. That means, again, I already mentioned, you take the paper. If you want to make it as a sphere or a ball, definitely you require one, you can call it just one point to glue those things. That point is your B. That is your B, which is not there in your complex plane. That means complex plane together with that point at infinity, we will call it as a extended complex plane. So that extended complex plane will be projected to this sphere, and this sphere will be projected to extended complex plane. And whatever this B points nearby B are called points at infinity. Okay? So such things is very usually difficult to understand or visualize only from blackboard. If you can use such things, it makes it. I have not mentioned many points here, so you can prepare a nice applet explaining such things, so that people can understand what is meant by stereographic projection, what is meant by Riemann sphere. Okay. Yes. So this is about this three-dimensional one. Yes. Any doubts?
No, sir. No, sir. Thank you.
Okay. So you can explore different types of things are here. For example, you can take a cone, then you can try to cut and see what different types of conic sections you will get. Those things. For example, here you can have, if I try to put, say, suppose cone, radius 3. So we have a cone here, right? Then this is basically, if you see from top, it just look like a circle. So, but this is how this is like cone or pyramid. If you want, you can invert that. Is not a problem. Okay. Yes. Then you can cut this with. So let me put some plane. So let me put a plane passing through 3 points. Let me put one here and one here. So this is a plane. Okay. So let me hide this one so that. So now we have these two planes, two different shapes. One is this one, and the other one is cone. Okay. Now, if you click on this intersect two surfaces, then select two surfaces. You select this one and the other one. Okay. Now you can go to algebra and you can hide these things to see what actually is the intersection of these two. What should be your guess? What is the intersection of these two? Means if you try to cut cone with a paper, what we will get? What we supposed to get? It should be a circle, right? Yes or no? You can check that from here. Say suppose I'll remove this plane and also I will hide this cone. Now what is here is basically just like you take an ice cream cone and try to cut it. Okay, what you will see is again just basically a circle, right? So you can have a different types of, say suppose you take a parabola, you take different one and try to cut, and you can see that what are all we are going to get in that. Okay, that is one. And then you can also try you can have a surface of revolution. So what is this surface of revolution is basically, let me clear that. So if it says is that drag curve around axis. Okay. So let me draw this. So for that first we want to put a curve. Let me put a curve here. Yes. So can you see this curve here? We should have some curve. Okay. So that curve is this. We have a curve here. This sin x, graph of sin x. So let me put like. Now I want to show you how we can have a three-dimensional one called surface of revolution. So I'll click on this surface of revolution. It says drag curve around x-axis. Yes. Can you see this? Yes or no? Can you see this one?
Yes, yes, yes. Nice, sir.
So what we have did here, basically we have, even though it is, we just created a three-dimensional picture using a single two-dimensional curve. Okay, it's just like sine graph we have seen. Then through this x-axis we have tried to rotate it. Okay, so you can have go to tools that algebra, and you can have a this, you can see here surface revolution. This, if I click on this, it will have, and this we can make it such type of images. We can make it using sliders also. Okay, sliders. How one can somebody tell how we can use slider here? Hmm? Yes. If you want to make it this, you have to take a line and try to rotate that through an angle. So if you rotate that through an angle, that is what here it is mentioned, 313 degrees 49. So if you try to rotate that through an angle, then this will be created. Suppose you take a circle and you join that circle with horizon and then try to rotate that. You see this one, you will get a cone. Okay.
Sir, can you rotate about y-axis and show?
Yes, yes. So let me clear this. So suppose now I go to this, is that surface. For everything, actually, you can write formulas also. Let me see here. Basically, where we have selected that function, based on that, it will rotate, right? You can see in this formula, algebra, you can check what we are using here. This is the function. The function was defined like this. If you want, earlier itself, we have to write, let's say, for example, f of y is equal to sine y. Okay. Just imagine you have a x-axis, and x-axis you have some curve. Okay. So obviously on which axis we have to rotate it? We have to rotate in an x-axis so that you get that shape. Yes or no? Right? This you can see partially I have rotated. Okay, so it is almost like impossible to rotate through that y-axis. So we have to define a function. So you take a curve in two dimensions, then try to rotate it. Or as I said, one can try to prepare a three-dimensional object with help of some circle, some line, try to join them. Okay, let me show that. Let me show one. Suppose I want to put some circle here. Okay, so go here. I want to have some circle. Let me quickly put some circle here. Okay. Suppose I'll circle with center, radius, and direction. Just a second. Here power light is gone. So I don't know how many time my internet will work here. Let me draw that circle here. I can write here f of circle with center. Select center point, then direction, then enter radius. Select circle point. Oh. Select center point, then direction, then radius. Hello? Just a second. I think my internet may disconnect soon. I just show you one so that you can try creating such one can take it as a, say for example, this I created a mug, this using whatever I just now said. Okay, so what I said here is, say for example, can you see this picture? Yes. Hello. Can you see this picture or not?
Yes, sir. Yes, sir. Yes, sir.
Yeah. So this is basically I created a line. Okay, B and C. Then what I did is I am rotating this function f. F is polynomial b comma c. That means it is a line joining b and c. So basically I have one line. Okay, then I am rotating that line through this slider called angle. Okay, so the moment you start from one place and rotate up to 360 degrees, that means we will come back to that place again, right? Then what we got here is just like from top angle, it is just like this. So you simply try to take one just like a line and we are rotating that, okay, so that it has just like look like a shape. Okay, you can have here bottom also you can create. So to create a bottom, what you require is you should have a circle and then this line. Then try to rotate that using this surface one. It is just half rotated. Okay, 180 degrees. So you can see from this that how it is keep rotating. That one line is just like keep dragging that line up to 360 degrees. That means it completes a rotation. Then you can find such figure here. Okay. You can make a lot of things using this three-dimensional and using that surface revolution. See, for example, here I have constructed with base also. Okay, so if I remove this, see that base is also half is going less. Yes or no? So basically what I have is two lines. So one line which is for like base. Okay, then you have one another line. So just like take L shape, for example. Then if you try to rotate that L shape, then what you get is you also get walls as well as below base also you will get. That's why if you keep rotating this, you can see here. Can you see this picture? This is, I mean, you are not doing anything extra mathematics or whatever. It is justly simply use of your surface function. This is like surface function, and for that you need your function. Our function is just a line joining B and A. Okay, and our S, which is angle, and what we are doing here is we are trying to rotate through some axis, and what that axis we are rotating through Z axis. Okay, if I put here instead of Z axis some other one, you will see that some different will come. Let me stop this and say suppose instead of Z axis, say suppose if I write Y axis and rotate it, then what you will see here, this is Y axis. Okay, this is X axis, this is Z axis. Okay, and if you keep doing this, it is we are doing that in through Z axis. Okay, so any angle we can rotate and we can try to visualize how it look like. Yes, any problem? Is that clear? So you can take a
Yes.
small a two-dimensional object, any object, then you can try to rotate it through anywhere. This F is simply line joining segment from A to B. That's all. This is A and B. We are trying to join that, and you will get this surface revolution using this surface function. You will get that. Okay. Yes. You can also have something called spreadsheets or graphing. This is three-dimensional. You can also have two-dimensional graph. Let me leave this because we have some 10-15 minutes time. You, if you go here, I think I'm still connected, right? Yes.
Yes, sir. Yes.
Yes. Here you can see this graphing calculator. If you click on this graphing calculator, it is basically two-dimensional graphing calculator. If I write here f of x is equal to x square, it is x square, parabola. Yes. So one can ask where it. Yeah. Can somebody tell how you can use sliders here? Huh? How one can use sliders? See, if you want to draw a line, y is equal to mx plus c. Then I can put some m. So easy way to create sliders is just if you write m and press enter, it will become a slider. Okay. So y is equal to mx plus c. Suppose I'll write c. See, this m and c are two constructed. Now I'll write. Let me erase this. I'll write y is equal to mx plus c. Okay. Then if I write this, and if I start this one, can you see this line is moving? Yes or no? M values and C values. So if you keep playing both, you can see different things you will have. Here also it is changing, angle also it is changing, right? So y is equal to mx plus c. Here also we can use it, what I can call sliders. Even for y, f of x is equal to x power n you can use it as a slider. So you can have, say for example, f of x is equal to ax square plus bx plus c, and you can have a, b, c, different values. Okay. So let me disable this. I'll remove this. So MC, and let me remove this also. So let me write f of x is equal to, say, something like m x square, okay, and plus c x. Okay. So now if I keep playing this, so what you will see here, for a different value of m and different value of x, we get this, right? And you can see differently it is when c value or m value is different, you are getting a different shape. So no, you can make animations like that. And how we use sliders, the moment you use sliders in proper way, you get better pictures. Okay. So this is one graph. You can have some graph, you can have a line, and you can ask where what are the roots of that graph, and all those things. You can have a different tools here. Some are basic, which are really always there. Okay. There is one last one which I would like to explain, and then we'll stop. A basic thing, because in school level, how we usually graph, first step is we try to put points 1 comma 2 2 comma 3. I mean this y is equal to x square. Then we'll put the values for x is equal to 0 1 2 3. Then we'll try to put the value of y is equal to x square, and we'll try to plot those things on that graph, and we will join that. Okay, you can use this best fit line for that. So where is this spreadsheet? You can go to spreadsheet. Let me see where is that spreadsheet. We go to later. We'll have spreadsheet. Let me take to that spreadsheet. I'll just close that by seeing one thing, which is spreadsheet view. So here you have spreadsheet. So that is usually how we do basically the first way of doing plotting a graph. Okay. So suppose I want the value of x here, then I will put the value of y here. Okay. Then I will put here the x comma y. Okay. So I'll put here some values, say 2 4 or 2 3 4 5. Then y is, say, some function. Say for example, I'll write y is equal to this 1 times, say suppose I'll write sometimes 5. It is just like if whatever value is there, we will multiply that by 5. So it becomes 10, and I can drag this. So we have different points. Then I want this one, which is x comma y. So obviously you select this, comma then this. Okay, let me put it coordinate form. Then this is 2 comma 10. So here 2 comma 10, 3 comma 15, 4 comma 20. So if you see this graph here, the moment we have created those points, they are already displayed here. C2, C3, C4, C5. Okay, you can uh, select these points and you can go to algebra and you can ask them to join. So it will fit that whatever things are there, it will try to join those points closely. It will join, or you can select these 2 points. Okay, and you can have here something like list or plot, then it will draw. You can have many things. So these are all the way you can explore GeoGebra. And with this basic introduction and using the resources, you can learn yourself almost all everything. At least you are getting some tutorials, trainings, or whatever, how one can explore. And many of us have learned on our own by taking the help of YouTube. So for example, I'll just show you on YouTube. If you just type this, as I said, Tim Brzezinski, he has lot of demonstrations. Yeah, here Tim Brzezinski GeoGebra. If you click on this, he has almost all type of how to create. Here just now I explained how to create a surface revolution in GeoGebra. Okay, so you take any type of function in one variable, then you try to rotate with different axis, then we get a surface revolution. For whoever want to learn, you can directly take his reference. You can start using these videos. This is what I said here. If you see in this picture, this is called virtual. Okay, so this whatever he designed using that app, one can keep it on your table virtually image. See, for example, in this it is. Let me show that one. Just one small is that Tim. Yeah. So can you see this? So whatever he said here, it is actually a picture. It is not virtual one. So he is trying to develop a three-dimensional object here, and he will try to verify that with that augmented reality. Okay, so you can learn how to do such things. Let me show you late at the end. Just a second. Sorry. Yeah, so he is trying to show how this can be projected. Yeah, this is now that it is created. This one can create using AR. This is called AR, augmented reality. So if you have a mobile app or tab, using that you can create augmented reality app. So yes, now you can see that on his table, he has put that augmented reality. Yes. Yes. Can you see this video? Yes.
Yes, sir.
So you can see that he is trying the image he has created with the actual image which is there already. So this augmented reality is very, very useful. One can design nice way of in every Android app. This feature is there. If you generate this, if you install this GeoGebra app on your mobile, and if you create any 3D object, that 3D object you can project it on any table wall using this augmented reality app. Okay, it is nice way. I mean, once it is correct, you can take that print also. Okay, so let me stop this. So this person, you can learn many things from him. Most of the things I have learned from him actually. Maybe I can stop here. If you have any doubts, we can clear it. Do you have any doubts? And there are some links here for different things. I can share it in chat box. You can save it. These are some of the links. It may be useful if you want to get some info. Any doubts?
Okay, sir. Are you done?
Yes, sir.
I think he's.
Yes.
Okay, sir. Thank you. So, in this 2 days workshop, we haven't really gone deep into this interesting world of GeoGebra, but we have done enough for us to explore things on our own after today's session. So, I hope everyone utilizes this knowledge in some way or the other. Now, we have almost reached to the end of this workshop. I would request our principal, Professor Javasio Mendes, to share his thoughts.
Thank you, Rohit. I hope I'm audible to all of you.
Yes, sir.
At
Yes,
the
sir.
outset, I must congratulate the postgraduate department of mathematics from our college for taking this lead. This satellite conference is in the run-up to the Axiom 2023 that we are planning to have under the leadership of Brian and the team members. Uh, I must thank Dr. Surendranath Reddy. I was there for a little part of your this, not being from the Department of Mathematics. Some of the things are, googlies for us, but I'm sure I could see a few others intently listening, and I'm sure as a run up to the Axiom 2023, people who have been attending will benefit a lot. Uh, Very interesting ideas. Thank you, Dr. Reddy, for being the resource person. I don't know whether Dr. Inder Rana is with us. He was supposed to be joining us, but I would like to place on record our sincere thanks to both of you, Dr. Surendranath Reddy and Dr. Inder Rana, for partnering in this very important educational cause. I would like to thank you, especially on behalf of the Government College of Arts, Science and Commerce, Sankili. And I'm sure these exercises that we are doing will be really fruitful. We approach the D-Day of having our Exam 2023. Now, this is the second edition, and many students are upbeat of participating into this. We not only have the local teams, but we also have outstation teams for taking part in this prestigious competition. We are also looking at long-term partnerships with our resource person. Dr. Reddy is here with us. We are certainly looking at establishing these partnerships because ultimately the goal is to ensure that we empower our students as much as possible. Thank you once again, and I would request either Rohit or Mr. Brian to take over. Thank you very much.
Thank you, sir.
Thank you, sir, for your kind words and support. Now, I would like to request, I would say, the most active participant of this workshop, Dr. Kala Nayak, the Registrar and HOD of Science and Humanities, Don Bosco College of Engineering, to share her views on this workshop and the resource persons.
Just to interrupt, I could see
Yes, sir.
Dr. Kala attending and attending very intently. Thank you, ma'am, and
Thank you, sir.
we are honored to have you as one of the attendees for this satellite conference. Thank you very much on behalf of the college. I
Thank you,
thank
sir.
you. Thank you very
Thank you,
much.
sir. Yeah, thank you, Rohit.
Yes.
At the outset, I would like to thank Government College of Arts, Science and Commerce, Sankurin, Goa. As principal said, I'm still a student of mathematics, And being little aged person, Reddy Garu, I don't know many of the things. Okay, basically I'm from Bangalore, and now I shifted to Goa recently, 6 years back. And one of our faculty members in one of the session in the college, because we conduct one session called cafe session. Of course, at the end of the day, we have coffee in the department. In that cafe session, she introduced GeoGebra, one of our faculty. And I said, wow, it is a wonderful thing. And recently, when I saw in our group, Maths Crazy People, there is one WhatsApp group. I said, yeah, thank you, Brian, for that. It's a wonderful opportunity for me to explore. That too from Rana sir and Reddy Garu sir. It's a wonderful. Reddy Garu sir, first of all, I'm not that fast, catchy person for the new software. As you know, because we are little old people, we little hesitate to click any of the buttons, in the computer. But still, I enjoyed a lot. Yesterday, I felt little bit easy, GeoGebra. Today, I felt I don't know how AR and VR we can utilize in GeoGebra. Wonderful session, sir. And as principal said, some of the things went tangentially, sir. To be frank with you, but still, I'll assure you that I'll see that we will train students using GeoGebra tool, because in our syllabus also we have surface of revolution, volume generation after revolution, and drawing of the tracing of the curve, etc. And when we teach them on blackboard, they don't visualize it. So this is wonderful tool for us to update ourselves and update our students also. From my heart, I am grateful to the college first, and Brian sir to put it in the WhatsApp group so that I could enroll for the 2 days workshop. And if possible, principal sir, kindly make it offline workshop. I will be the first person to enroll for that. Thank you for the wonderful session. To Rana
Suggestion
sir
noted,
also in
ma'am.
his absence. Yeah, please,
Suggestion
sir.
noted. Suggestion
Yes, sir.
noted.
Thank you,
Yeah,
sir.
yeah.
Thank you very much.
And ma'am, the reason for having this online was specifically because of the outstation teams, because
I
the teams from Delhi and all couldn't come for that one day
Yes.
prior. So that was the only reason we had it online for the outstation teams.
Yeah.
Yeah.
Next time, please, for us, sir, for Goan, please, 2 or 3 days workshop offline, please
Yes,
conduct for us. We will
because
be there.
one need to explore on their hands.
Yes, sir. Then only we can say it is a workshop.
Yes.
No, otherwise you can't follow up whether I learnt it or not.
Yes.
That's the reason. Thank you very much to both all of you, sir. Thank you, Rohit.
Thank you, ma'am.
Thank you, ma'am. Okay, I would now request Mukan D'Souza, a student, to share his view on this workshop. Mukan, are you there?
Yes, sir. I would like to thank Dr. Reddy and Dr. Rana for conducting this very informative workshop on utilizing GeoGebra, which will be very useful for us in our future career, and to enrich our mathematical knowledge. We enjoyed following your step-by-step instructions on how to use the various features of GeoGebra. Thank you very much, sir.
Thank you, Mukan. Okay, so now I move on to the last part of this two-day workshop, that is a vote of thanks, a formal vote of thanks. So I request Mr. Amit Thakur, Assistant Professor in Mathematics, to give the vote of thanks. Over to you, Amit.
Yeah, in between, Rohit, if possible,
Okay, yes, ma'am.
everyone can switch on their camera for one photo session. If possible, no? You can
Okay,
click.
whoever can switch on their cameras can do that.
Maybe Rohit, you can change your one of the screenshots will have to be taken. I'm on the phone, so I probably you probably shift.
It's on a phone, but I took a screenshot.
You take your layout to the maximum possible in settings and probably
I'll
take it.
try. I'll see if it is possible, because
Many are off. I mean, videos are off. Otherwise,
Yeah.
I can take here from here. Computer. Maybe once
Also,
again
you
we
can
can
put your
request Rohit.
videos on. Yes. You can put your videos on. So can you see how many are there, sir?
There are
40.
totally
Reddy, sir.
32. Yeah, but
40.
No,
40.
with videos on, I'm saying. With videos on.
only few. Maybe having
Only a few.
network issue, Rohit.
Yes, ma'am.
10, 15. Around 10, 15 are there.
Okay, sir.
That should
So
be
if you
okay.
can take a
Okay,
photo or
smile.
something. Because I am also on my phone,
Smile.
so I can see only 8 people around. Yeah.
Yeah, one I took. One more. Okay, one more time. Smile. Yes.
Thank you, sir.
Yes, thanks, Reddy.
Okay, sir. Thank you.
Thanks, Dr. Reddy.
Okay.
Welcome.
Okay, so I request Mr. Amit Thakur, Assistant Professor in Mathematics, to give the formal vote of thanks. Over to you, Amit.
Good evening, everyone. It gives me an immense pleasure to deliver the vote of thanks for this workshop. On behalf of the college, I would like to thank Dr. Inder Kirana sir and Dr. B. Surendranath Reddy sir for sharing their experience and knowledge with us and making our learning experience enjoyable and informative. I'm sure that we will be applying this knowledge to make the mathematics more fun. Thank you, sir. Now, I would like to place and record our thanks to Principal of our college, Dr. Gervasio Mandis, sir, for his encouragement and support for conducting this workshop. Sincere thanks to Rohit Redkar, Sir Brian D'Souza, and Sir Aaron for handling this workshop throughout. Also, I would like to thank Postgraduate Department of Mathematics for their support. Thanks to the Directorate of Higher Education, Government of Goa, and Directorate of Science, Technology and Waste Management, Government of Goa for their support. Thanks to Afsha Sheikh, Teja Parsekar, Mukan D'Souza, and Shubham Pai for their designing brochure and certificate. Finally, I would like to thank all the participants for attending the workshop. Your active participation and interest have made this workshop a great success. Thank you to one and all.
By the way, has
Thank
the
you, Amit.
attendance has the attendance sheet been circulated for this session?
I have circulated the attendance sheet and it will be open for more 20 or 30 minutes.
20 minutes. So to all parties, because the automation is contingent on that that you fill the attendance and the feedback, and that will automatically then generate your certificate and be mailed to you. So make sure you don't forget that.
Yes, sir. So just the final thing, I would like to say thank you to Yos Brian sir for letting me handle this workshop, and also Aaron sir for working with all the technical things. Thank you,
That's
sir.
the trust in the team.
Yes, sir.
Thank you,
Thank you,
Brian.
thank you. I mean, you've done
Congratulations
good.
to you.
Yes, sir.
And thanks to all the participants who've attended throughout. I mean, without the participants, we wouldn't have gone forward. So much of enthusiastic response we got, as well as, attending to these sessions. And I hope now, not only it starts here now for all participants, that you go back and, download GeoGebra, have it on your desktop, work online, as I said, and, come back maybe in the next workshop with some more advanced topics with us, Dr. Reddy telling some more advanced. I think the scripting was there. There was a little bit of scripting he hinted at. I think Java or Python. I'm not sure what is used, but yeah, in the, some programming can be done in the next workshop maybe. Okay, thank you.
Okay, yes, sir. We can stop the meet, right?
Yes, we can stop. By the way, Reddy, I couldn't join the Google Meet because I was handling the YouTube, trying to ensure that YouTube was going okay. But I was attending, but then I couldn't interact with you at the start because I was busy there.
I hope people will like and explore and produce some good applets to the competition.
Yes, yes. I
We
mean,
will try our
definitely.
level best. Yeah, thank you.
So,
Okay, thanks so much.
when is the competition?
The competition is on 3rd and 4th of
Yeah.
March.
Okay.
And quite a few of those will also be live streamed. So we will share those links. A part of the competition, we have quizzes like history of maths quiz. Then there is some debate competition. So there are 20 such competitions. One of them is the GeoGebra Applet making competition. So maybe when they present the applets to the judges, that aspect of it will be streamed online. So they will be explaining how their applet works. So I'll
Yeah,
definitely share the link.
applets one can share with anyone. You can create one
Yes.
group and let them share the GeoGebra applet so that anyone can see it.
Okay. Okay. Definitely.
Okay then. Best wishes
Yes.
to all.
Then
Take care.
Thank you, sir.
yes. Thanks. Thanks, Reddy.